Hello students, welcome back. Let's solve the next set of questions of electricity chapter from NCERT class 10 science book. The first question is, on what factors does the resistance of a conductor depend? Second question, will the current flow more easily through a thick wire or a thin wire of same material when connected to the same source? Why? Third, let the resistance of the electrical component remain constant while the potential difference across the ends of the component decreases to half of its former value. What change will occur in the current through it? The fourth question is, why are coils of electric toasters and electric irons made of an alloy rather than pure metal? And the last question is, use the data in table 11.2 to answer the following questions. Which among iron and mercury is a better conductor, and which material is the best conductor? Alright, so we'll have the table later on, but first let's solve the first question. On what factors does the resistance of a conductor depend? The formula for resistance of a conductor is given by the formula R is equal to rho L by A, where R is the resistance of the conductor, L is the length of the conductor, A is the area of cross section of the conductor, that is how thick or how thin the conductor is, and fourth, the resistivity of the material of the conductor, that is the nature of material, what kind of material we have chosen. So it will be different for different materials. That means if you take a same length of copper and iron wire having same thickness, they will offer different kinds of resistance. It's because of their resistivity. So resistivity depends on the nature of the material. Since these two materials are of different nature, they will provide different amount of resistance. So from this we can say that the resistance of a conductor varies directly as the length of the conductor. It varies inversely as the area of cross section of the conductor. Resistance varies directly as the nature of material of the conductor, and resistance varies directly as the temperature of the conductor. That is, if the temperature of the conductor increases, the resistance will increase. So summarizing this, we'll write the answer as, the resistance of a conductor depends on the following factors. Temperature of the conductor, R varies directly as the temperature. Cross-sectional area of the conductor, resistance varies inversely as the area of cross-section of the conductor. Length of the conductor, resistance varies directly as the length of the conductor. And nature of material of the conductor, resistance varies directly as the nature of material of the conductor. So this is the answer to the first question. Let's go to the next one. The next question is, will current flow more easily through a thick wire or a thin wire of the same material when connected to the same source? Why? So the current flowing in a conductor depends upon the resistance. So less is the resistance, more will be the current flow, and more is the resistance, less will be the current flow. We know this from Ohm's law, V is equal to IR. Now the resistance of the conductor depends on the thickness of the wire, whether it's a thick wire or a thin wire. Now we know that resistance is equal to rho L by A. Now from this we know that resistance varies inversely as the area of cross section of the conductor. That is, the lesser will be the area of cross section, the more will be the resistance, and the greater will be the area of cross section, the lesser will be the resistance. It is because when a certain number of electrons are moving through a thin wire, they are getting a certain amount of space to move. They are experiencing a certain amount of collision among themselves, which is resulting in the resistance of the wire. Now if you increase the thickness of the wire, the same amount of electrons now are getting more space to travel. So the amount of collision with themselves will be less, as a result of which they will experience less collision among themselves. So the resistance will be less. So we see that the greater area of cross section provides lesser resistance, and lesser area of cross section provides more resistance. So here the resistance will be higher and here the resistance will be lower. So the answer to this question will be, resistance is given by the equation R is equal to rho L by A, where rho is the resistivity of the material of the wire, L is the length of the wire, A is the area of cross section of the wire. Hence from this equation it is clear that the resistance is inversely proportional to the area of cross section of the wire. Therefore the thinner the wire, the more is the resistance, and vice versa. Hence current flows more easily through a thick wire than a thin wire. So I hope you have understood this. Let's go over to the next question. The next question is, let the resistance of an electrical component remains constant while the potential difference across the two ends of the component decreases to half its former value. What change will occur in the current through it? So here we have the resistance remaining constant what changes will occur in the current passing through the conductor if the potential difference is decreased to half of its former value. So we'll solve this using Ohm's law, that is V is equal to IR. So we'll write here from Ohm's law V is equal to IR. Now it's saying that the resistance of the conductor remains constant. So here if we keep the resistance constant, so V will vary directly as the current, that is potential difference will vary directly as the current if the resistance of the conductor is kept constant. Now since current varies directly as the potential difference across its ends, now if the potential difference reduces to half of its value, the current also will decrease accordingly to half of its value. How? Let's solve this through this equation. Now we know that V is equal to IR, R is constant. Now V dash, the new V dash is half of the original value, and we have to find out the new current I dash, what will be its value. Now we know from Ohm's law V is equal to IR. So I will be V by R, but we want to find out the new current. The new current I dash will be V dash by R. Now I dash will be, what is V dash? V dash will be V by 2 and R. So taking the constant outside, it's 1 by 2 V by R. But what is V by R? Now from this equation we know that I is equal to V by R. So if this is your equation 1, so we can write here it is 1 by 2 I. So hence we get the new current I dash is I by 2. That is, the new current will be half of the previous current. The new current will be half of the original value. So this is the answer to this question. So I hope you have understood this. Let's solve the fourth question. Why are coils of electric toasters and electric irons made of an alloy rather than a pure metal? Before we answer this question, I hope you know about alloy. Now alloy is a mixture of two or more metals combined together in some fixed proportion. When we combine the metals to form alloys, it becomes a totally new substance. Its resistivity also changes accordingly. The resistivity of an alloy is generally higher than that of its constituent metals. Hence, the resistance of alloys is higher than that produced by its constituent metals. Secondly, alloys do not oxidize or burn readily at higher temperature. That is, at higher temperature, there is a chance that individual metals might burn out or oxidize. But when they are combined to form alloys, this doesn't happen. So, this is the reason that we choose the heating elements of electric toasters and irons to be made from alloy rather than a pure metal. So this one you can see the heating element of an iron, and this one is the heating element of a toaster. So here you can see these all are made up of alloys, and these heating elements are made up of alloys. So I hope you are clear with the answer to this question. Let's go over to the next question. Use the data in table 11.2 to answer the following questions. Which among iron and mercury is a better conductor, and which material is the best conductor? So let's write down the resistivity of iron and mercury from this table. So the value of resistivity of iron is 10 into 10 to the power minus 8 ohm meter, and the resistivity of mercury is 94 into 10 to the power minus 8 ohm meter. So we know that from the formula for resistance, R is equal to rho L by A. Now from here we see that if length and area of cross section of the wire remains constant, resistance varies directly as the resistivity rho. So resistance is directly proportional to the resistivity of the conductor. So higher the resistivity, higher is its resistance. So here we see that the resistivity of mercury is more than that of iron. Hence, resistance of mercury is greater than the resistance of iron. Since the resistivity of mercury is more than that of iron, hence the resistance of mercury is more than the resistance of iron. Hence, iron would provide a lower resistance to the flow of current in the conductor. Thus, iron is a better conductor than mercury. Next question is, which material is the best conductor? Now, the material with the lowest value of resistivity will be the best conductor. So, from this table, we see that the lowest resistivity is provided by silver with a resistivity of 1.6 into 10 to the power minus 8 ohm meter. Hence, silver is the material with the lowest resistivity and hence it is the best conductor. So, the answer to the second question is silver. So, these are the answers to these questions. I hope you've understood the solutions to all of these. That's all for today. If this video was helpful to you, please like it, share it and subscribe to the channel if you are new to it. Thanks for watching. Please watch the playlist containing the solved physics questions and numericals from the previous year's board exams. I've shared the link of the playlist in the description box. It will be very helpful to you while preparing for your exams.